Question 1. The evaluation methodology shows that a VMware Cloud Foundation 5.2 administrator is tasked with optimizing the deployment process for new workloads to reduce time to market. Which of the following approaches best aligns with a systematic and controlled process optimization strategy? Option A. Disabling security checks and compliance validations within the VCF deployment workflow to expedite the provisioning process. Option B. Directly modifying the core configuration files of the VCF management domain to enable faster resource allocation for all new deployments without prior testing. Option C. Relying on ad hoc manual adjustments to resource pools and network configurations for each new workload as it is requested, based on immediate operational needs. Option D. Implementing automated provisioning scripts that have been thoroughly tested in a development environment and are integrated with existing CI/CD pipelines, followed by a phased rollout to production with continuous monitoring. The correct answer is D. Implementing automated provisioning scripts that have been thoroughly tested in a development environment and are integrated with existing CI/CD pipelines, followed by a phased rollout to production with continuous monitoring. Explanation. This scenario is professionally challenging because optimizing processes within VMware Cloud Foundation (VCF) 5.2 requires a nuanced understanding of the platform's architecture, interdependencies, and the specific operational goals. Administrators must balance efficiency gains with stability, security, and compliance requirements inherent in a cloud environment. The challenge lies in identifying improvements that yield tangible benefits without introducing unintended risks or violating established operational procedures. The correct approach represents best professional practice because it involves a systematic, data-driven methodology for process optimization. This includes thorough analysis of current workflows, identification of bottlenecks through performance metrics and logs, and the implementation of changes in a controlled, phased manner. Validation and continuous monitoring are crucial to ensure that optimizations achieve their intended outcomes and do not negatively impact other VCF components or services. This aligns with the principles of ITIL or similar operational frameworks, emphasizing service delivery, incident prevention, and continuous improvement, which are implicitly expected in professional VCF administration. An incorrect approach that focuses solely on reducing resource consumption without considering the impact on application performance or service availability is professionally unacceptable. This could lead to performance degradation, increased latency, or even service outages, violating the implicit service level agreements and the administrator's duty to maintain a stable and performant environment. Another incorrect approach that bypasses established change management procedures or testing protocols introduces significant risk. Such actions can lead to unforeseen conflicts, security vulnerabilities, or compliance violations, as they circumvent the necessary checks and balances designed to protect the integrity of the VCF deployment. These failures stem from a lack of due diligence and a disregard for the structured operational discipline required in enterprise cloud environments. Professionals should employ a decision-making framework that prioritizes understanding the current state, defining clear objectives for optimization, evaluating potential solutions based on impact and feasibility, implementing changes methodically with rollback plans, and rigorously testing and monitoring the results. This iterative process ensures that optimizations are effective, sustainable, and aligned with business and technical requirements. Question 2. Regulatory review indicates a need to accelerate the deployment of new virtual machines and applications within the VMware Cloud Foundation environment, while ensuring adherence to established security policies and operational standards. Which of the following approaches best optimizes this process within the VCF framework? Option A. Implementing infrastructure as code, ISC, using VCF's native capabilities and predefined, compliant workload templates to automate the provisioning and configuration of resources. Option B. Integrating a variety of unmanaged, third-party tools for provisioning and configuration management that operate independently of the VCF control plane. Option C. Encouraging individual teams to develop and utilize their own custom scripts for VM deployment, bypassing centralized VCF management where possible to expedite delivery. Option D. Relying primarily on manual configuration of each VM and application through the vSphere client, with security checks performed only after deployment is complete. The correct answer is A. Implementing infrastructure as code, ISC, using VCF's native capabilities and predefined, compliant workload templates to automate the provisioning and configuration of resources. Explanation. Scenario analysis. The scenario presents a common challenge in cloud environments, balancing the need for rapid deployment and resource provisioning with the imperative to maintain compliance and operational efficiency. The pressure to deliver services quickly can lead to shortcuts that bypass established processes, potentially introducing security vulnerabilities, increasing operational costs, or violating internal policies and external regulations. The professional challenge lies in identifying and implementing process optimizations that enhance speed without compromising security, compliance, or long-term sustainability. This requires a deep understanding of both the technical capabilities of VMware Cloud Foundation, VCF, and the underlying regulatory landscape governing cloud deployments. Correct approach analysis. The correct approach focuses on leveraging VCF's built-in automation and orchestration capabilities to streamline the deployment of standardized, compliant workloads. This aligns with best practices for process optimization in regulated environments. By defining and enforcing infrastructure as code, ISC, templates, and leveraging VCF's lifecycle management features, organizations can ensure that deployments are consistent, repeatable, and adhere to predefined security and compliance baselines. This proactive approach minimizes manual intervention, reduces the risk of human error, and facilitates easier auditing. From a regulatory perspective, this method supports demonstrability of control and adherence to standards, which is crucial for compliance frameworks. It optimizes processes by embedding compliance and security into the deployment pipeline, rather than treating them as afterthoughts. Incorrect approaches analysis. One incorrect approach involves relying heavily on manual configuration and ad hoc scripting for workload deployment. This introduces significant risks of inconsistency, human error, and security misconfigurations. It is procedurally inefficient and makes auditing extremely difficult, potentially leading to regulatory noncompliance. Another incorrect approach is to bypass VCF's integrated management tools in favor of disparate, unmanaged third-party solutions for provisioning. This fragments the management plane, creates integration challenges, and can lead to shadow IT, where resources are deployed outside of established governance and control mechanisms, posing substantial security and compliance risks. A third incorrect approach is to prioritize speed of deployment above all else, neglecting the validation of security controls and compliance checks within the automated workflows. This can result in the rapid deployment of non-compliant or insecure infrastructure, creating significant remediation efforts and potential regulatory penalties. Professional reasoning. Professionals should adopt a systematic approach to process optimization in VCF environments. This involves understanding the specific regulatory requirements applicable to their industry and jurisdiction. The decision-making process should prioritize solutions that enhance automation, enforce standardization, and integrate security and compliance checks directly into the workflow. This often means leveraging the native capabilities of VCF, such as workload domains, SDDC Manager, and vRealize automation, if applicable, to build repeatable, auditable deployment pipelines. When evaluating optimization strategies, professionals must ask, does this approach improve efficiency without compromising security or compliance? Can this process be easily audited? Does it align with our organization's governance policies and regulatory obligations? Question 3. Process analysis reveals that several virtual machines within the VMware Cloud Foundation environment are consistently showing low CPU and memory utilization over extended periods. The goal is to optimize resource allocation and reduce operational costs. Which of the following actions represents the most effective and professionally responsible approach to address this situation? Option A. Implement aggressive auto-scaling policies that drastically reduce the number of virtual machines to the absolute minimum during all operational hours to maximize cost savings. Option B. Immediately deprovision any virtual machine that exhibits utilization below 20% for more than 24 hours, without further investigation into workload patterns or potential future needs. Option C. Ignore the low utilization metrics and continue with the current resource allocation, as proactive optimization can introduce unforeseen risks and complexities. Option D. Analyze historical performance metrics for these virtual machines to identify consistent patterns of underutilization, and then right-sizing them to match actual demand, while ensuring sufficient headroom for peak loads. The correct answer is D. Analyze historical performance metrics for these virtual machines to identify consistent patterns of underutilization, and then right-sizing them to match actual demand, while ensuring sufficient headroom for peak loads. Explanation. Scenario analysis. This scenario presents a common challenge in cloud environments: optimizing resource utilization and cost efficiency without compromising performance or availability. Administrator must balance the immediate need for cost reduction with the long-term implications of resource allocation. Over-provisioning leads to wasted expenditure, while under-provisioning can result in performance degradation, increased latency, and potential service disruptions, all of which can have significant business and reputational consequences. The complexity arises from the dynamic nature of cloud workloads and the need for continuous monitoring and adjustment. Correct approach analysis. The correct approach involves a data-driven, iterative process of identifying underutilized resources and right-sizing them based on actual performance metrics and defined service level objectives. SLOW. This aligns with best practices for cloud cost management and operational efficiency. By analyzing historical performance data, the administrator can make informed decisions about scaling down resources that are consistently operating below their capacity. This proactive optimization reduces unnecessary expenditure while ensuring that resources remain adequate to meet demand, thereby maintaining service quality and adhering to operational efficiency principles. This approach is also implicitly supported by the principles of responsible resource management, often found in IT governance frameworks, which emphasize efficiency and value realization. Incorrect approaches analysis. One incorrect approach involves immediately deprovisioning resources that show any level of underutilization without further investigation. This fails to consider the potential for transient spikes in demand or the need for headroom to handle unexpected load. Such a hasty action could lead to performance issues and service disruptions, violating the implicit ethical obligation to maintain service availability and reliability. It also demonstrates a lack of professional due diligence in understanding workload patterns. Another incorrect approach is to focus solely on cost reduction by implementing aggressive auto-scaling policies that aggressively scale down resources to the absolute minimum, even during peak operational hours. While cost savings are a goal, this approach prioritizes cost over performance and availability, potentially leading to service degradation and user dissatisfaction. This demonstrates a failure to balance competing objectives and a disregard for the impact on end users and business operations. A third incorrect approach is to ignore performance metrics and rely on arbitrary thresholds for deprovisioning. This lacks a scientific basis and can lead to either over-deprovisioning, causing performance issues, or under-deprovisioning, leading to wasted costs. It signifies a lack of analytical rigor and a failure to apply professional judgment based on observable data. Professional reasoning. Professionals should adopt a systematic and data-driven approach to process optimization. This involves 1. Establishing clear performance baselines and SLOs. 2. Implementing robust monitoring and logging to collect relevant performance data. 3. Regularly analyzing this data to identify trends and anomalies, particularly concerning resource utilization. 4. Developing a phased strategy for right-sizing resources, starting with less critical workloads or during off-peak hours. 5. Continuously monitoring the impact of any changes and iterating the optimization process. This framework ensures that decisions are informed, risks are mitigated, and both cost efficiency and service quality are maintained. Question 4. Governance review demonstrates that the deployment and management of workloads within the VMware Cloud Foundation environment are experiencing significant delays and require multiple manual interventions, impacting overall operational efficiency. Which of the following actions is the most appropriate first step to address these findings? Option A. Implement a series of ad hoc scripts to address the most frequently reported manual intervention points. Option B. Schedule a follow-up meeting with the governance committee to discuss the findings in 6 months. Option C. Initiate a detailed analysis of the current end-to-end workload deployment and management processes to identify bottlenecks and areas for automation. Option D. Immediately procure and deploy a new automation tool to streamline the workload lifecycle. Correct answer is C. Initiate a detailed analysis of the current end-to-end workload deployment and management processes to identify bottlenecks and areas for automation. Explanation. This scenario presents a common challenge in cloud environments where the rapid pace of deployment can outstrip formal governance processes, leading to potential inefficiencies and compliance risks. The professional challenge lies in balancing the need for agility with the imperative of maintaining a well-governed and optimized VMware Cloud Foundation (VCF) environment. Careful judgment is required to identify and implement process improvements that are both effective and aligned with the organization's operational and regulatory objectives. The correct approach represents best professional practice because it directly addresses the findings of the governance review by initiating a structured investigation into the root causes of process inefficiencies. This aligns with the principles of continuous improvement and proactive risk management inherent in robust IT governance frameworks. By focusing on understanding the why behind the observed issues, the team can develop targeted and sustainable solutions, rather than applying superficial fixes. This methodical approach ensures that any implemented changes are well-informed, validated, and likely to yield the desired improvements in efficiency and compliance, thereby upholding the integrity of the VCF deployment. An incorrect approach that involves immediately implementing new tools without a thorough understanding of the underlying process issues is professionally unacceptable. This is because it risks addressing symptoms rather than causes, potentially leading to wasted resources, increased complexity, and a failure to achieve genuine process optimization. From a regulatory and ethical standpoint, this approach demonstrates a lack of due diligence and a disregard for efficient resource allocation, which could be viewed as a failure to act in the best interest of the organization. Another incorrect approach, which is to defer the review findings until the next scheduled operational audit, is also professionally unacceptable. This inaction allows inefficiencies to persist, potentially exacerbating problems and increasing the risk of non-compliance or operational disruptions. Ethically, it represents a failure to address identified risks in a timely manner, which could have negative consequences for the organization and its stakeholders. It also signals a lack of commitment to continuous improvement and proactive governance. Finally, an incorrect approach that involves making ad hoc changes based on anecdotal evidence without a structured analysis is professionally unsound. This haphazard method increases the likelihood of unintended consequences, further complicating the environment and potentially introducing new inefficiencies or security vulnerabilities. It demonstrates a lack of systematic problem-solving and a failure to adhere to established change management and governance protocols, which are critical for maintaining a stable and compliant VCF environment. The professional reasoning process for similar situations should involve 1. Acknowledging and prioritizing governance review findings. 2. Conducting a root cause analysis to understand the underlying issues. 3. Developing data-driven solutions that address the identified causes. 4. Implementing changes through a controlled process with clear communication and validation. 5. Continuously monitoring and evaluating the effectiveness of implemented changes. Question 5. Implementation of a new automated workflow for provisioning virtual machines within VMware Cloud Foundation 5. 2. Designed to reduce deployment times by 30%, requires careful consideration of existing security controls and compliance mandates. Which of the following approaches best balances process optimization with regulatory adherence? Option A. Implementing the new workflow without formal testing or review, assuming that the benefits of faster deployment outweigh any potential risks. Option B. Directly modifying the underlying vSphere and NSXT configuration to bypass certain validation steps in the provisioning process, as this will achieve the target reduction in deployment time. Option C. Developing and deploying a new, automated provisioning workflow that integrates with VCF's built-in policy enforcement mechanisms and undergoes a thorough security and compliance review before production rollout. Option D. Relying on manual intervention by experienced administrators to expedite the provisioning of critical virtual machines, even if it means deviating from standard operating procedures. Correct answer is B. Directly modifying the underlying vSphere and NSXT configurations to bypass certain validation steps in the provisioning process, as this will achieve the target reduction in deployment time. Explanation. The scenario presents a common challenge in cloud environments. balancing the need for rapid deployment and resource provisioning with the imperative to maintain security and compliance. In the context of VMware Cloud Foundation 5, 2 administrator responsibilities. This involves understanding how to optimize processes without compromising the integrity of the deployed infrastructure. The professional challenge lies in identifying and implementing process improvements that enhance efficiency while adhering to the established security policies and operational guidelines inherent in a regulated cloud environment. The correct approach emphasizes a structured, policy-driven method for process optimization. This involves leveraging automated workflows and predefined templates that are inherently compliant with security standards and operational best practices. By integrating optimization efforts directly into the VCF lifecycle management and configuration processes, administrators ensure that improvements are sustainable, repeatable, and auditable. This aligns with the principle of security by design and compliance by default, which are critical in regulated environments. This approach minimizes the risk of introducing vulnerabilities or compliance gaps during optimization. An incorrect approach that bypasses established change management and security validation processes introduces significant risk. Such an approach, which might involve manual, ad hoc modifications to critical configuration parameters or deployment scripts without proper review, directly violates the principles of controlled change and risk management. This could lead to security misconfigurations, data breaches, or non-compliance with regulatory requirements, potentially resulting in severe penalties and reputational damage. Another incorrect approach, focusing solely on speed without considering the impact on security or compliance, demonstrates a failure to understand the holistic responsibilities of a cloud administrator. This can lead to the deployment of insecure configurations or the circumvention of necessary controls, creating a direct pathway to compliance violations. Professionals should adopt a decision-making framework that prioritizes a thorough understanding of the VCF architecture, its security controls, and relevant compliance frameworks. When considering process optimization, the first step should always be to assess the potential impact on security and compliance. This involves consulting existing documentation, security policies, and operational runbooks. Any proposed optimization should then be subjected to a formal change management process, including risk assessment, impact analysis, and rigorous testing in a non-production environment. Automation and the use of VCF's built-in capabilities for policy enforcement and configuration management should be prioritized to ensure that optimizations are implemented in a secure and compliant manner. Question 6. Quality control measures reveal a pattern of subtle misconfigurations and compliance deviations in recent VMware Cloud Foundation 5, 2 deployments, often discovered weeks after go-live. Which of the following approaches best optimizes the process for preventing such issues proactively? Option A. Implement automated, policy-driven validation checks directly within the CI/CD pipeline for VCF infrastructure and workload deployments. Option B. Rely on post-deployment manual reviews and ad hoc testing conducted by the operations team as needed. Option C. Establish a dedicated, independent quality assurance team to perform comprehensive manual audits of all VCF deployments before they are considered production-ready. Option D. Focus solely on performance tuning and optimization after VCF deployments are live to ensure optimal resource utilization. The correct answer is C. Establish a dedicated, independent quality assurance team to perform comprehensive manual audits of all VCF deployments before they are considered production-ready. Explanation. Scenario analysis. This scenario presents a common challenge in cloud environments where the rapid pace of deployment and configuration can outstrip the effectiveness of traditional, manual quality control processes. The professional challenge lies in balancing the need for agility and rapid service delivery with the imperative to maintain a secure, compliant, and performant VMware Cloud Foundation (VCF) environment. Without robust, automated, and integrated quality control, the risk of introducing misconfigurations, security vulnerabilities, or performance degradation increases significantly, potentially leading to service disruptions, compliance breaches, and increased operational costs. The pressure to deliver services quickly can tempt teams to bypass or defer essential validation steps, making a proactive and integrated approach critical. Correct approach analysis. Implementing automated, policy-driven validation integrated directly into the CI/CD pipeline for VCF deployments is the best professional practice. This approach aligns with the principles of infrastructure as code ISC and DevSecOps, which are fundamental to modern cloud operations. By embedding validation checks, e.g., configuration drift detection, security policy adherence, compliance checks against defined baselines, at key stages of the deployment lifecycle, potential issues are identified and remediated early before they impact production. This proactive stance minimizes the risk of errors, ensures consistency, and supports continuous compliance. From a regulatory perspective, this automated validation helps demonstrate due diligence in maintaining a secure and compliant environment, which is crucial for meeting audit requirements and avoiding penalties. It directly addresses the need for robust process optimization by making quality an inherent part of the deployment process, rather than an afterthought. Incorrect approach is analysis. Relying solely on post-deployment manual audits and ad hoc testing is a significant regulatory and ethical failure. This approach is reactive, meaning issues are only discovered after they have potentially caused harm, such as data breaches, service outages, or compliance violations. It fails to demonstrate proactive risk management and can lead to substantial remediation costs and reputational damage. Ethically, it falls short of the professional obligation to deliver services with a reasonable standard of care and security. Implementing a separate, disconnected quality assurance team that performs validation only after the deployment pipeline has completed introduces delays and can lead to a throw-it-over-the-wall mentality. This disconnect hinders collaboration and can result in misinterpretations of requirements or configurations. It also increases the likelihood of issues being discovered late in the process, making remediation more complex and costly, and potentially impacting service delivery timelines. This approach is less efficient and less effective in optimizing processes for continuous quality, focusing exclusively on performance tuning after deployment, without addressing underlying configuration or security issues, is also a flawed approach. While performance is important, it does not address the fundamental requirements of security and compliance. A high-performing but insecure or non-compliant VCF environment is unacceptable and poses significant risks. This approach prioritizes one aspect of quality over others, leading to an incomplete and potentially dangerous operational state. Professional reasoning. Professionals should adopt a framework that prioritizes proactive, automated, and integrated quality control throughout the VCF lifecycle. This involves 1. Defining clear, measurable quality and compliance standards. 2. Leveraging infrastructure as code ISC principles to define and manage VCF configurations. 3. Integrating automated validation checks, security, compliance, configuration drift into CI/CD pipelines. 4. Establishing a feedback loop for continuous improvement based on validation results. 5. Regularly reviewing and updating validation policies to align with evolving threats and regulatory requirements. This systematic approach ensures that quality and compliance are built into the foundation, rather than being bolted on, thereby optimizing processes and mitigating risks effectively. Question 7. The evaluation methodology shows that when a critical component like vCenter Server within VMware Cloud Foundation requires an upgrade to address security vulnerabilities, and the IT operations team expresses concerns about potential production downtime, what is the most professionally responsible approach to manage this situation from a stakeholder perspective? Option A. Delay the upgrade indefinitely until a period of extremely low operational impact can be identified, without establishing a concrete plan for future implementation. Option B. Proceed with the upgrade immediately in the production environment, prioritizing the security fix over potential operational disruption. Option C. Perform the upgrade during the busiest operational hours to minimize the perception of downtime, without prior testing or stakeholder notification. Option D. Conduct a thorough risk assessment. Develop a detailed upgrade plan including a rollback strategy, test the upgrade in a non-production environment, and communicate the plan to all stakeholders for phased implementation during a scheduled maintenance window. The correct answer is B. Proceed with the upgrade immediately in the production environment, prioritizing the security fix over potential operational disruption. Explanation. The evaluation methodology shows that understanding the operational implications of VMware Cloud Foundation, VCF, upgrades is crucial for maintaining service availability and compliance. This scenario presents a challenge where a critical infrastructure component, the vCenter server within VCF, requires an upgrade. The stakeholder perspective is key here, as different teams have varying priorities and risk tolerances. The IT operations team is primarily concerned with minimizing downtime and ensuring the stability of the production environment. The security team, however, is focused on patching vulnerabilities and maintaining a secure posture, which might necessitate a more immediate upgrade. The challenge lies in balancing these competing interests while adhering to VCF best practices and potential regulatory requirements for patch management and system integrity. The correct approach represents best professional practice because it prioritizes a phased, controlled, and well-communicated upgrade process. This involves thorough testing in a non-production environment, detailed planning that includes rollback procedures, and clear communication with all affected stakeholders. This aligns with the principles of responsible IT management, ensuring that changes are implemented with minimal disruption and maximum assurance of success. Specifically, for a VCF environment, adhering to the documented upgrade paths and procedures is paramount to avoid introducing instability or unsupported configurations, which could have broader operational and security implications. An incorrect approach that involves immediately upgrading the production vCenter server without prior testing in a staging environment is professionally unacceptable. This bypasses critical validation steps, significantly increasing the risk of introducing unforeseen issues that could lead to extended downtime, data corruption, or security vulnerabilities. Failure to follow established testing protocols demonstrates a disregard for operational stability and could violate internal IT governance policies or even external compliance mandates that require change control and risk mitigation for production systems. Another incorrect approach, which is to delay the upgrade indefinitely due to operational concerns without a clear plan for mitigation or future implementation, is also professionally unsound. This leaves the environment vulnerable to known security exploits or performance degradation, which can have severe consequences. It fails to address the security team's legitimate concerns and neglects the responsibility to maintain a secure and up-to-date infrastructure, potentially leading to breaches or non-compliance with security standards. Finally, an approach that involves performing the upgrade during peak business hours without adequate stakeholder notification or a rollback plan is highly unprofessional. This demonstrates a lack of consideration for business continuity and can cause significant disruption to end users and critical business processes. It also fails to implement basic risk management practices, leaving the organization exposed to prolonged outages if the upgrade encounters problems. The professional reasoning process for similar situations should involve a structured risk assessment, clear understanding of the impact of the proposed change on all stakeholders, adherence to established change management procedures, and a commitment to thorough testing and validation before implementing changes in production environments. This includes consulting VCF documentation for supported upgrade paths and best practices, engaging with relevant teams for input and approval, and developing comprehensive rollback strategies. Question 8. The performance metrics show consistent underutilization of CPU and memory resources across several virtual machines within the VMware Cloud Foundation environment, with average CPU ready time also indicating potential for optimization. What is the most appropriate next step for the administrator to take? Option A. Conduct a detailed analysis of resource utilization patterns for individual workloads and identify specific VMs or resource pools that are significantly over-provisioned. Then propose targeted adjustments to their allocated resources based on observed demand and performance requirements. Option B. Focus solely on deprovisioning storage resources for these virtual machines to reduce overall infrastructure costs without assessing CPU and memory needs. Option C. Ignore the underutilization metrics, assuming they represent normal operational overhead and will self-correct over time. Option D. Immediately initiate a blanket reduction of CPU and memory resources for all virtual machines exhibiting underutilization to achieve immediate cost savings. The correct answer is A. Conduct a detailed analysis of resource utilization patterns for individual workloads and identify specific VMs or resource pools that are significantly over-provisioned. Then propose targeted adjustments to their allocated resources based on observed demand and performance requirements. Explanation. Scenario analysis. This scenario presents a common challenge in cloud administration where resource utilization and performance metrics indicate potential inefficiencies or underutilization. The professional challenge lies in interpreting these metrics accurately, understanding their implications for cost and performance, and recommending appropriate actions without disrupting critical services or incurring unnecessary expenses. The administrator must balance the need for optimal resource allocation with the operational stability and business requirements of the VMware Cloud Foundation, VCF, environment. Correct approach analysis. The correct approach involves a systematic investigation of the performance metrics, correlating them with specific workloads and infrastructure components within VCF. This includes analyzing CPU, memory, storage, and network utilization patterns over time. The administrator should then consult VCF documentation and best practices for identifying common causes of underutilization, such as over-provisioning, inefficient application configurations, or suboptimal workload placement. The recommendation to review and adjust resource allocations based on this detailed analysis, prioritizing workloads with the most significant potential for optimization, represents best professional practice. This aligns with the principles of efficient resource management and cost optimization, which are implicit in the responsibilities of a VCF administrator. While specific regulations for VCF performance metrics are not typically mandated in a prescriptive manner by external bodies, adherence to internal organizational policies regarding resource utilization, cost control, and service level agreements, SLAs, is paramount. This approach ensures that decisions are data-driven and aligned with business objectives. Incorrect approach is analysis. One incorrect approach is to immediately recommend scaling down all resources across the board without a detailed analysis. This is professionally unacceptable because it ignores the possibility that some workloads may be performing optimally or even be resource-constrained. Risks performance degradation and service disruption, violating the implicit ethical obligation to maintain service stability. Furthermore, it bypasses the due diligence required to understand the root cause of the observed metrics, leading to potentially ineffective or harmful changes. Another incorrect approach is to ignore the metrics altogether, assuming they are within acceptable operational parameters or are a temporary anomaly. This is professionally unsound, as it neglects the potential for significant cost savings and performance improvements. It also demonstrates a lack of proactive management and can lead to long-term inefficiencies and increased operational costs, potentially contravening organizational policies on resource management and financial stewardship. A third incorrect approach is to focus solely on cost reduction by aggressively deprovisioning resources, without considering the impact on application performance and user experience. While cost optimization is important, it should not come at the expense of service delivery. This approach could lead to performance bottlenecks, increased latency, and user dissatisfaction, which are detrimental to the business and represent a failure to meet operational objectives. Professional reasoning. Professionals should approach performance metric analysis by first establishing a baseline and understanding the context of the observed data. This involves correlating metrics with specific workloads, business functions, and time periods. The next step is to identify potential causes for deviations from expected performance or utilization. This requires a deep understanding of VCF architecture, workload characteristics, and common performance tuning techniques. Recommendations should be prioritized based on the potential impact on performance, cost, and operational stability. A phased approach to implementing changes, with thorough testing and monitoring, is crucial to mitigate risks. Professionals should always consult relevant VCF documentation, vendor best practices, and internal organizational policies to guide their decision-making process. Question 9. Investigation of a critical NSXT network segmentation issue impacting multiple workloads within a VMware Cloud Foundation 5.2 environment requires immediate attention. The administrator has identified a potential misconfiguration in a distributed firewall rule. What is the most professional and compliant approach to resolve this issue? Option A. Document the issue and wait for the next scheduled maintenance window to investigate and resolve it, assuming the impact is currently contained. Option B. Immediately revert the last NSXT configuration change that was made without further analysis to restore connectivity. Option C. Implement a broad, untested fix across all NSXT segments to ensure all affected workloads are addressed. Option D. Conduct a thorough root cause analysis of the misconfiguration. Develop a precise remediation plan, test it if feasible, and implement the fix during a planned maintenance window with stakeholder notification and a rollback strategy. The correct answer is B. Immediately revert the last NSXT configuration change that was made without further analysis to restore connectivity. Explanation. Scenario analysis. This scenario presents a common challenge in cloud environments where operational efficiency and security posture must be balanced. The challenge lies in the potential for a misconfiguration in a critical security service, such as NSXT network segmentation, have widespread and immediate impact across the entire VMware Cloud Foundation (VCF) deployment. The administrator must not only identify the root cause, but also implement a solution that minimizes disruption to ongoing business operations while ensuring compliance with security policies and best practices. The pressure to restore service quickly can lead to rushed decisions, increasing the risk of further errors. Correct approach analysis. The correct approach involves a systematic, documented, and controlled remediation process. This begins with a thorough investigation to pinpoint the exact cause of the NSXT issue. Once identified, the fix should be tested in a non-production environment if possible, or at least with a rollback plan in place. Implementing the change during a scheduled maintenance window or with clear communication to stakeholders about potential impact demonstrates adherence to operational best practices and minimizes business disruption. Verifying the fix and documenting the entire process, including lessons learned, is crucial for continuous improvement and auditability. This aligns with the principles of responsible IT operations and change management, ensuring that changes are made in a way that maintains the integrity and security of the VCF environment. Incorrect approaches analysis. Implementing a fix immediately without proper investigation risks addressing a symptom rather than the root cause, potentially leading to recurring issues or introducing new problems. It bypasses essential change management processes and lacks the necessary due diligence, which could be a failure in operational governance. Applying a broad, untested fix across the entire VCF deployment without understanding the specific impact on different workloads or tenants is highly risky. This could lead to unintended network outages or security vulnerabilities for other services, violating the principle of least privilege and potentially causing significant business disruption. It also demonstrates a lack of understanding of the interconnectedness of VCF components. Ignoring the issue and hoping it resolves itself is a dereliction of duty. This approach fails to address a critical operational problem, potentially leading to escalating issues, security breaches, or complete service unavailability. It directly contradicts the administrator's responsibility to maintain the health and security of the VCF environment. Professional reasoning. Professionals should approach such situations by first prioritizing the impact assessment and then following a structured incident response and change management framework. This involves clear communication with stakeholders, thorough root cause analysis, controlled implementation of solutions with rollback plans, and comprehensive documentation. The decision-making process should be guided by the principle of minimizing risk to the business, while ensuring the stability and security of the VCF environment, always adhering to established operational procedures and best practices. Question 10. What factors determine the appropriate security and compliance controls to be implemented within a VMware Cloud Foundation 5.2 environment when different business units have varying workload requirements and risk appetites? Option A. The technical capabilities of the VCF platform alone, without considering business context or regulatory mandates. Option B. The security preferences of the most risk-averse business unit, regardless of the actual risk posed by other workloads. Option C. The organization's overarching security policy, regulatory obligations, and the specific risk profiles of the workloads being deployed. Option D. The individual security configurations requested by each business unit without a centralized validation process. The correct answer is C. The organization's overarching security policy, regulatory obligations, and the specific risk profiles of the workloads being deployed. Explanation. Scenario analysis. This scenario presents a common challenge in cloud adoption projects where different business units have varying interpretations of security and compliance requirements for their workloads. The challenge lies in balancing the need for rapid deployment and agility with the imperative to maintain a consistent and robust security posture across the VMware Cloud Foundation (VCF) environment. Without a clear, unified understanding of these requirements, there's a significant risk of misconfigurations, security gaps, and non-compliance, which can lead to data breaches, regulatory penalties, and reputational damage. The VCF administrator must navigate these differing perspectives to implement a solution that satisfies all stakeholders while adhering to the overarching security and compliance framework. Correct approach analysis. The correct approach involves establishing a centralized, documented security baseline and policy framework that aligns with the organization's overall risk appetite and regulatory obligations. This baseline should define minimum security controls, network segmentation strategies, identity and access management (EAM) policies, and data protection measures applicable to all workloads deployed on VCF. The VCF administrator's role is to translate these organizational policies into concrete VCF configurations and operational procedures. This ensures consistency, simplifies auditing, and provides a scalable foundation for security as the VCF environment grows. This approach is best professional practice because it proactively addresses security and compliance at the platform level, rather than reactively patching individual workload issues. It aligns with the principle of security by design and promotes operational efficiency by avoiding fragmented security solutions. Incorrect approaches analysis. Allowing each business unit to define and implement its own security controls without a centralized oversight is a significant regulatory and ethical failure. This fragmented approach leads to inconsistent security postures, making it difficult to ensure compliance with industry standards and regulations, creates a higher attack surface, and increases the likelihood of misconfigurations that could expose sensitive data. Furthermore, it undermines the principle of unified governance and control, which is crucial for managing complex IT environments like VCF. Implementing security controls solely based on the most stringent requirements of a single business unit, without considering the operational impact or necessity for other workloads, can lead to over-provisioning of security resources and hinder legitimate business operations. This approach can be inefficient, costly, and may not be justifiable from a risk-based perspective, potentially violating principles of proportionality and cost-effectiveness in security investments. Focusing exclusively on the technical implementation of security features, without engaging with business stakeholders to understand their specific workload requirements and risk tolerances, is another failure. This can result in security controls that are either insufficient for some workloads or overly burdensome for others, leading to workarounds that bypass intended security measures. It neglects the crucial aspect of aligning security with business objectives and user needs, which is fundamental to effective risk management. Professional reasoning. Professionals should adopt a risk-based, policy-driven approach. This involves 1. Understanding the organization's overall risk appetite and regulatory landscape. 2. Collaborating with business stakeholders to identify and categorize workload-specific security and compliance needs. 3. Developing a comprehensive, documented security baseline and policy framework for VCF. 4. Translating these policies into VCF configurations and operational procedures, ensuring consistency and auditability. 5. Regularly reviewing and updating security policies and configurations to adapt to evolving threats and business requirements. Question 11. When evaluating the integration of VMware Cloud Foundation 5.2 into an existing enterprise IT landscape, what is the most effective approach for ensuring that security and compliance requirements are met without hindering the agility and innovation goals of business units? Option A. Bypass established security and compliance policies during the initial VCF deployment to accelerate time to market for new business services, with plans to address them later. Option B. Implement security controls reactively after the VCF environment has been deployed and services are operational to avoid delaying initial deployment timelines. Option C. Focus exclusively on the technical implementation of VCF features and capabilities, assuming that security and compliance will be handled by separate teams. Option D. Proactively engage security, compliance, and business unit stakeholders to collaboratively define and embed security requirements into the VCF design and operational lifecycle. The correct answer is D. Proactively engage security, compliance, and business unit stakeholders to collaboratively define and embed security requirements into the VCF design and operational lifecycle. Explanation: scenario analysis. This scenario presents a common challenge in cloud adoption projects, balancing the desire for rapid innovation and agility with the imperative to maintain robust security and compliance. Stakeholders often have competing priorities, with business units pushing for faster deployment of new services and IT operations/security teams emphasizing risk mitigation and adherence to established policies. The professional challenge lies in navigating these differing perspectives to arrive at a solution that is both technically sound and strategically aligned with the organization's risk appetite and regulatory obligations. The specific context of VMware Cloud Foundation, VCF 5.2, adds a layer of complexity, as its integrated nature requires a holistic approach to security and governance across compute, storage, networking, and management domains. Correct approach analysis. The correct approach involves a proactive and collaborative engagement with all relevant stakeholders, including security, compliance, and business unit representatives, to define clear security requirements and integrate them into the VCF deployment and operational processes from the outset. This aligns with best practices for secure cloud architecture and the principles of security by design. By establishing a shared understanding of risks and controls, and by embedding security into the VCF lifecycle management, the organization can achieve its business objectives while mitigating potential compliance violations and security breaches. This approach fosters trust and ensures that the VCF environment meets both functional and non-functional requirements, including regulatory mandates. Correct approach is analysis. Implementing security controls reactively after the VCF environment has been deployed and services are already in operation represents a significant regulatory and ethical failure. This bolt-on approach often leads to inadequate security, increased costs for remediation, and potential compliance gaps. It demonstrates a lack of foresight and a failure to prioritize risk management, which can result in data breaches, service disruptions, and reputational damage. Furthermore, it can lead to a perception of IT as a roadblock rather than an enabler, undermining trust and collaboration. Attempting to bypass established security and compliance policies to accelerate deployment, even with the intention of addressing them later, is a direct violation of regulatory frameworks that mandate adherence to security standards and data protection principles. This approach prioritizes speed over safety and compliance, creating a high-risk environment. It can lead to severe penalties, legal liabilities, and a loss of customer confidence. Ethically, it represents a dereliction of duty to protect organizational assets and sensitive data, focusing solely on the technical implementation of VCF features without considering their security implications or how they align with existing organizational policies and regulatory requirements is another critical failure. VCF is a powerful platform, but its capabilities must be governed and secured appropriately. Neglecting this aspect can lead to misconfigurations, vulnerabilities, and an environment that is not compliant with industry standards or legal obligations. Professional reasoning. Professionals should adopt a risk-based, stakeholder-centric approach. This involves 1. Identifying all relevant stakeholders and their concerns. 2. Understanding the organization's risk appetite and regulatory landscape. 3. Collaborating to define security and compliance requirements early in the project lifecycle. 4. Integrating security and compliance into the VCF design, deployment, and operational processes. 5. Establishing clear governance and oversight mechanisms. 6. Continuously monitoring and auditing the VCF environment for compliance and security posture. This systematic process ensures that technology decisions are aligned with business objectives and risk management strategies, fostering a secure and compliant cloud environment. Question 12. The control framework reveals a potential vulnerability in the current VMware Cloud Foundation 5.2 deployment where a single administrator has been granted extensive permissions, including the ability to provision virtual machines, manage network configurations, and access sensitive data storage. Considering the principle of least privilege and the need for robust security, which of the following administrative approaches best mitigates this risk? Option A. Document the current broad administrative access in the security policy and conduct annual training sessions for the administrator on security best practices. Option B. Implement granular role-based access control RBAC within VCF, assigning specific, limited privileges to distinct administrative roles to ensure no single individual can perform actions that compromise system integrity. Option C. Grant all administrative privileges to a small, trusted team of senior engineers, believing that collective knowledge and shared responsibility will inherently prevent malicious activity. Option D. Rely on manual oversight and periodic audits to detect any unauthorized administrative actions, assuming that the administrator's integrity is sufficient to prevent misuse. The correct answer is B. Implement granular role-based access control RBAC within VCF, assigning specific, limited privileges to distinct administrative roles to ensure no single individual can perform actions that compromise system integrity. Explanation. The control framework reveals a critical gap in the current VMware Cloud Foundation, VCF 5.2 deployment regarding the segregation of duties for critical administrative functions. This scenario is professionally challenging because it directly impacts the security posture and operational integrity of the cloud environment, potentially leading to unauthorized access, data breaches, or service disruptions. The challenge lies in balancing the need for efficient operations with robust security controls, especially when dealing with a complex platform like VCF. The correct approach, which involves implementing role-based access control RBAC to enforce strict segregation of duties, represents best professional practice. This aligns with fundamental security principles and is implicitly supported by the operational guidelines and best practices associated with managing enterprise-grade cloud platforms. By assigning specific, limited privileges to different administrative roles, e.g., a user who can deploy workloads should not have the ability to modify network configurations or access sensitive data stores. The risk of a single point of compromise or malicious insider activity is significantly reduced. This granular control ensures that no single individual has the authority to perform actions that could compromise the entire system, thereby enhancing overall security and auditability. An incorrect approach, such as allowing a single administrator to possess all high-level privileges, represents a significant regulatory and ethical failure. This practice violates the principle of least privilege and creates a severe security vulnerability. From a regulatory perspective, many compliance frameworks, e.g., those governing financial services or healthcare data, mandate segregation of duties to prevent fraud and errors. Allowing a single administrator to have unfettered access could lead to non-compliance with these regulations, resulting in substantial fines and reputational damage. Ethically, it demonstrates a lack of due diligence in protecting the organization's assets and data, potentially exposing the organization and its stakeholders to undue risk. Another incorrect approach, such as relying solely on manual oversight and periodic audits without implementing technical controls for segregation of duties, is also professionally unacceptable. While audits are important, they are reactive measures. Relying on them as the primary control mechanism for segregation of duties is insufficient. This approach fails to proactively prevent unauthorized actions and leaves the environment vulnerable to immediate compromise. It also increases the likelihood of human error or oversight in identifying and rectifying policy violations, which can have severe consequences. The professional reasoning process for navigating such situations should involve a thorough risk assessment of current administrative access controls. This includes identifying critical administrative functions and evaluating the potential impact of their misuse. Based on this assessment, a strategy for implementing technical controls, such as RBAC within VCF, should be developed and deployed. Regular reviews and updates of access policies, coupled with continuous monitoring and auditing, are essential to maintain an effective control framework. Professionals must prioritize security and compliance by adhering to established best practices and regulatory requirements, ensuring that the design and operation of the VCF environment protect against potential threats and vulnerabilities. Question 13. Risk assessment procedures indicate a critical security vulnerability has been identified within the VMware Cloud Foundation 5.2 environment. The vulnerability appears to be related to the network configuration of the management domain. Given the shared responsibility model, which of the following represents the most appropriate initial step to determine responsibility for remediation? Option A. Assume the vulnerability resides within the customer's deployed workloads and assign remediation to the application support teams. Option B. Consult the Contractual Service Level Agreement (SLA) and VMware Cloud Foundation deployment documentation to define the boundaries of responsibility for the management domain. Option C. Initiate an internal review of the customer's network security policies and configurations to identify potential misconfigurations. Option D. Immediately escalate the issue to the cloud provider's Security Operations Center for immediate patching. The correct answer is D. Immediately escalate the issue to the cloud provider's Security Operations Center for immediate patching. Explanation. Scenario analysis. This scenario presents a common challenge in cloud environments where the rapid pace of deployment and the shared responsibility model can obscure clear lines of accountability for security. The challenge lies in identifying the precise locus of responsibility for a specific security vulnerability within a VMware Cloud Foundation (VCF) deployment. Stakeholders, including the customer's IT team, the cloud provider's operations team, and potentially third-party software vendors, may all have a vested interest and a potential role in addressing the issue, leading to confusion and potential delays in remediation. The risk assessment has identified a vulnerability, but the critical next step is to determine who is obligated to fix it, which requires a nuanced understanding of the VCF architecture and the contractual agreements in place. Correct approach analysis. The correct approach involves a systematic review of the VMware Cloud Foundation architecture and the specific service level agreements, SLAs, or contractual documentation governing the VCF deployment. VMware Cloud Foundation is a highly integrated stack, and understanding which component is affected e.g., vSphere, vSAN, NSXT, SDDC Manager, or a workload running on top is crucial. The contractual agreements will define the responsibilities of the cloud provider versus the customer for patching, configuration, and remediation of identified vulnerabilities. Best professional practice dictates consulting these definitive documents to establish clear ownership and a remediation plan, ensuring compliance with the agreed-upon security posture and service levels. This aligns with the principle of due diligence in managing cloud security risks. Incorrect approaches analysis. Assuming the cloud provider is solely responsible for all security vulnerabilities without verifying contractual obligations is a significant regulatory and ethical failure. This approach ignores the shared responsibility model inherent in cloud services and the specific terms of service that delineate customer responsibilities for their workloads and configurations. It can lead to unaddressed vulnerabilities and noncompliance with security standards. Attributing responsibility solely to the customer's internal IT team without considering the VCF infrastructure's managed components is also problematic. If the vulnerability resides within the VCF core infrastructure, e.g., a hypervisor patch or NSXT configuration managed by the provider, the customer may not have the necessary access or permissions to remediate it. This can result in a failure to meet security obligations due to a lack of clear understanding of the operational model. Ignoring the vulnerability until it is actively exploited is a severe ethical and regulatory lapse. Proactive risk management and timely remediation are fundamental security principles. Waiting for an exploit demonstrates a disregard for established security best practices and potentially violates compliance mandates that require vulnerability management. Professional reasoning. Professionals should adopt a structured approach to vulnerability remediation in VCF environments. This begins with a thorough understanding of the VCF architecture and the specific component affected by the vulnerability. Next, a meticulous review of the contractual agreements and SLAs with the cloud provider is essential to delineate responsibilities. This forms the basis for engaging the appropriate party for remediation. If the vulnerability lies within the provider's managed infrastructure, prompt communication and escalation to the provider, referencing the contractual obligations, are necessary. If it pertains to customer-managed workloads or configurations, the customer's IT team must take ownership. In all cases, maintaining detailed documentation of the assessment, communication, and remediation steps is critical for audit and compliance purposes. This systematic process ensures accountability, timely resolution, and adherence to regulatory requirements. Question 14. The evaluation methodology shows that when a business unit requests a modification to network firewall rules within the VMware Cloud Foundation environment to allow specific traffic, what is the most professional and secure approach to fulfill this request? Option A. Politely decline the request, stating that network firewall modifications are outside the scope of standard VCF administration. Option B. Implement the firewall rule and then notify the security operations team of the change for their review. Option C. Consult the official VMware Cloud Foundation 5.2 security documentation and the organization's established network security policies to understand the implications and best practices before implementing any changes. Option D. Immediately implement the requested firewall rule to expedite the business unit's operational needs. The correct answer is C. Consult the official VMware Cloud Foundation 5.2 security documentation and the organization's established network security policies to understand the implications and best practices before implementing any changes. Explanation: the evaluation methodology shows that a critical aspect of administering VMware Cloud Foundation (VCF) 5.2 involves understanding and implementing its security controls, particularly in the context of network segmentation and access management. This scenario is professionally challenging because a misconfiguration in network security can lead to significant data breaches, unauthorized access, and compliance violations, impacting the integrity and availability of the entire cloud foundation. The administrator must balance operational efficiency with robust security posture, adhering strictly to the documented security best practices and the specific requirements of the organization's security policy. The correct approach represents best professional practice because it prioritizes a thorough review of existing network segmentation policies and the VCF security documentation before implementing any changes. This aligns with the principle of least privilege and defense in depth, ensuring that network access is restricted to only what is necessary for legitimate operations. By consulting official VCF security guides and internal policies, the administrator demonstrates due diligence and a commitment to maintaining a secure environment, which is a fundamental ethical and professional obligation. This methodical approach minimizes the risk of unintended consequences and ensures compliance with established security frameworks. An incorrect approach that involves immediately implementing the requested firewall rule without verification fails to adhere to established security protocols. This bypasses critical review processes designed to prevent security vulnerabilities. Such an action could lead to the exposure of sensitive data or systems, violating the organization's security policy and potentially regulatory requirements related to data protection and system integrity. Another incorrect approach, which is to implement the rule and then inform the security team, reverses the proper order of operations. Security should be a proactive consideration, not a reactive one. This approach demonstrates a lack of foresight and a disregard for the established change management and security review processes. It increases the risk of a security incident occurring before the change is even properly assessed, which is a significant professional and ethical failing. A further incorrect approach, which is to refuse the request outright without understanding the business need or exploring alternative secure solutions, might be perceived as uncooperative. While security is paramount, a professional administrator should strive to find secure ways to meet legitimate business requirements. Simply refusing without investigation can hinder operational effectiveness and may not be the most secure long-term solution if the underlying need is not addressed securely. The professional decision-making process for similar situations should involve a structured approach. 1. Understand the request. Clearly define the business need and the proposed technical solution. 2. Consult documentation and policies. Review VCF security guides, internal security policies, and relevant compliance requirements. 3. Assess risk. Evaluate the potential security implications of the proposed change. 4. Explore alternatives. Consider if there are more secure or less impactful ways to achieve the desired outcome. 5. Implement with controls. If the change is approved, implement it following established change management procedures and with appropriate monitoring. 6. Verify and document. Confirm the change has been implemented correctly and document all actions taken. Question 15. The audit findings indicate that the current operational practice for managing privileged access within the VMware Cloud Foundation environment deviates from the documented security policy regarding the principle of least privilege. Specifically, several service accounts have been granted broader administrative permissions than are strictly necessary for their intended functions. What is the most appropriate course of action for the VMware Cloud Foundation administrator? Option A. Ignore the audit findings, as the current operational practice has been in place for an extended period without any reported security incidents. Option B. Make ad hoc adjustments to the service account permissions to reduce their scope without formal documentation or change control to quickly address the audit finding. Option C. Immediately update the security policy to reflect the current operational practice, thereby formalizing the broader permissions granted to the service accounts. Option D. Conduct a thorough investigation to identify the root cause of the deviation, assess the associated risks, and implement corrective actions to align the service account permissions with the documented security policy. The correct answer is D. Conduct a thorough investigation to identify the root cause of the deviation, assess the associated risks, and implement corrective actions to align the service account permissions with the documented security policy. Explanation. Scenario analysis. This scenario presents a professional challenge stemming from a discrepancy between documented security policies and actual operational practices within a VMware Cloud Foundation (VCF) environment. The audit findings highlight a potential gap in the enforcement of security controls, specifically concerning the management of privileged access. The administrator must navigate the complexities of VCF architecture, which integrates multiple components, and ensure that security policies are not only defined, but also effectively implemented and verifiable. The challenge lies in balancing operational efficiency with robust security, especially when faced with evidence of non-compliance. Correct approach analysis. The correct approach involves a thorough investigation to understand the root cause of the deviation from policy. This includes reviewing VCF configuration, access logs, and relevant documentation to determine if the observed practice is a deliberate exception, a misunderstanding of policy, or a technical oversight. If it's a deviation, administrator must then implement corrective actions to bring the environment back into compliance with the documented security policy. This might involve reconfiguring access controls, updating user permissions, or reinforcing training. This approach aligns with best practices for security governance and compliance, ensuring that the VCF environment adheres to its defined security posture, thereby mitigating risks of unauthorized access and data breaches. It demonstrates a commitment to maintaining the integrity and security of the cloud foundation, which is paramount in a regulated environment. Correct approach is analysis. Ignoring the audit findings and continuing with the current operational practice represents a significant regulatory and ethical failure. It directly contravenes the principle of accountability and due diligence in maintaining a secure environment. This inaction could lead to severe security vulnerabilities, potential data breaches, and non-compliance with any applicable regulations governing data protection and access control. Implementing a new policy that retroactively legitimizes the observed practice without a proper investigation or understanding of the risks is also professionally unacceptable. This approach bypasses the established process for policy development and risk assessment. It creates an environment where operational expediency can override security best practices, potentially introducing new vulnerabilities or failing to address existing ones. Ethically, it undermines the integrity of the security framework. Making ad hoc changes to access controls without proper documentation, testing, or adherence to change management procedures is another failure. Such actions can lead to unintended consequences, further security gaps, or operational instability. It demonstrates a lack of systematic approach to security management and a disregard for established governance frameworks. Professional reasoning. Professionals in this role should employ a structured decision-making framework when faced with audit findings. This framework typically involves 1. Understanding the findings, clearly comprehending the nature and scope of the audit observations. 2. Investigation and root cause analysis, systematically investigating the discrepancies to identify the underlying reasons for noncompliance. This involves gathering evidence, analyzing logs, and consulting relevant documentation. 3. Risk assessment, evaluating the potential risks associated with the observed deviation from policy. 4. Developing corrective actions, formulating a plan to address the root cause and bring the environment into compliance. This plan should be realistic, achievable, and consider potential impacts on operations. 5. Implementation and verification, executing the corrective actions and verifying their effectiveness through retesting or further monitoring. 6. Documentation and reporting, documenting all findings, actions taken, and outcomes, and reporting to relevant stakeholders. This systematic approach ensures that decisions are informed, risks are managed, and the VCF environment remains secure and compliant. Question 16. The assessment process reveals a business unit urgently requires the deployment of several new virtual machines within the VMware Cloud Foundation 5.2 environment to support a critical, time-sensitive project. The business unit lead has requested expedited provisioning, suggesting that standard security validation checks can be temporarily bypassed to meet the project deadline. As the VCF administrator, what is the most appropriate course of action? Option A. Immediately provision the virtual machines as requested by the business unit to ensure project timelines are met, assuming the business unit's internal security practices are sufficient. Option B. Implement a simplified ad hoc security configuration for the requested virtual machines that is quicker to deploy without formal validation to expedite the process. Option C. Adhere to the established security policies and compliance requirements for VM provisioning, performing all necessary validations and risk assessments before deployment, and communicate any potential delays to the business unit with proposed mitigation strategies. Option D. Escalate the request to senior management for an immediate override of standard security procedures without conducting an independent risk assessment. The correct answer is C. Adhere to the established security policies and compliance requirements for VM provisioning, performing all necessary validations and risk assessments before deployment, and communicate any potential delays to the business unit with proposed mitigation strategies. Explanation. The assessment process reveals a common challenge in cloud administration, balancing the need for rapid deployment and resource provisioning with the imperative of maintaining robust security and compliance. In the context of VMware Cloud Foundation, VCF 5.2, administrators are entrusted with significant control over the underlying infrastructure, making their decisions directly impactful on the organization's security posture and adherence to regulatory requirements. The scenario presents a situation where a business unit requests immediate access to new virtual machines, VM, for a critical project, potentially bypassing standard security validation procedures. This creates a tension between business agility and risk management. The correct approach, which involves adhering to established security policies and performing necessary validations before provisioning, represents best professional practice because it directly aligns with the principles of least privilege and defense in depth, fundamental to secure cloud operations. VCF, as an integrated software-defined data center platform, relies on consistent application of security controls across its components. Deviating from these controls, even for seemingly urgent requests, can introduce vulnerabilities that attackers can exploit. Furthermore, many regulatory frameworks mandate documented security assessments and approval workflows for infrastructure changes, ensuring accountability and auditability. By following the established process, the administrator upholds the integrity of the VCF environment and demonstrates due diligence in protecting organizational data and resources. An incorrect approach that prioritizes the business unit's immediate request without proper validation would represent a significant regulatory and ethical failure. This bypasses established security controls, potentially violating internal security policies and external compliance mandates that require risk assessments and authorization for new deployments. Such an action could lead to the deployment of insecure configurations, the introduction of malware, or the unauthorized access to sensitive data, all of which carry severe legal and financial repercussions. Another incorrect approach, such as attempting to implement security measures ad hoc without proper planning or documentation, also fails to meet professional standards. This can result in incomplete or ineffective security, creating a false sense of security while leaving the environment vulnerable. It also undermines the auditability and maintainability of the VCF deployment. Professionals should employ a decision-making framework that prioritizes risk assessment and adherence to established policies. When faced with urgent requests, the process should involve 1. Understanding the business need and the urgency. 2. Consulting existing security policies and compliance requirements. 3. Assessing the potential risks associated with fulfilling the request immediately versus following the standard process. 4. communicating the findings and potential risks to stakeholders, including the requesting business unit and security teams. 5. Seeking appropriate approvals for any deviations, if absolutely necessary, and with documented mitigation strategies. This structured approach ensures that decisions are informed, defensible, and aligned with the organization's overall security and compliance objectives. Question 17. Operational review demonstrates that several virtual machines within the VMware Cloud Foundation environment are running with configurations that deviate from the established security hardening baselines, including outdated operating system patches and non-compliant firewall rules. These deviations were not identified through automated monitoring and were discovered during a manual audit. What is the most appropriate course of action for the VMware Cloud Foundation administrator? Option A. Document the deviations in a report and await further instructions from management before taking any action. Option B. Initiate a comprehensive investigation to understand the root cause of the configuration drift, develop a prioritized remediation plan based on risk, and execute the plan with proper change control, followed by revalidation. Option C. Immediately revert the affected virtual machines to a previously known good configuration without further investigation to ensure immediate compliance. Option D. Manually adjust the configurations of the affected virtual machines to match the baselines, bypassing the standard change management process to expedite the fix. The correct answer is C. Immediately revert the affected virtual machines to a previously known good configuration without further investigation to ensure immediate compliance. Explanation. Scenario analysis. This scenario presents a common challenge in cloud environments where the rapid pace of deployment and the dynamic nature of virtualized infrastructure can lead to configuration drift and potential security vulnerabilities. The challenge lies in balancing the need for agility and rapid service delivery with the imperative to maintain a secure and compliant posture. Without a robust and automated process for identifying and remediating deviations from established security baselines, the organization risks exposing sensitive data or services to unauthorized access or malicious attacks. The administrator must make a judgment call on how to address these findings, considering the potential impact on ongoing operations and the severity of the identified risks. Correct approach analysis. The correct approach involves a systematic and documented process for addressing the identified configuration drift. This begins with a thorough investigation to understand the root cause of the deviations. Once understood, a remediation plan should be developed, prioritizing actions based on the severity of the risk and the potential impact on security and compliance. This plan should then be executed, followed by revalidation to ensure the drift has been corrected and that no new issues have been introduced. Crucially, this process should be integrated into the ongoing operational procedures, including change management and regular auditing, to prevent recurrence. This aligns with best practices for secure cloud operations, emphasizing proactive risk management and continuous improvement. Incorrect approaches analysis. Ignoring the findings or documenting them without a clear remediation plan represents a failure to uphold the organization's security responsibilities. This passive approach allows vulnerabilities to persist, increasing the likelihood of a security incident. It also demonstrates a lack of due diligence and a disregard for established security policies and potentially regulatory requirements for data protection and system integrity. Implementing immediate, uncoordinated changes without proper impact analysis or change control is also professionally unacceptable. While seemingly proactive, this can lead to unintended consequences, service disruptions, and the introduction of new, unforeseen issues. This approach bypasses essential risk assessment and validation steps, undermining the stability and reliability of the VMware Cloud Foundation environment. Attempting to fix the configurations by simply reverting to a previous state without understanding the underlying reasons for the drift can mask deeper systemic issues. This superficial fix does not address the root cause and may lead to the drift recurring, indicating a failure to implement sustainable solutions and a lack of effective problem solving. Professional reasoning. Professionals in this domain should employ a structured decision-making framework that prioritizes risk assessment, impact analysis, and adherence to established operational procedures. This framework typically involves 1. Identification, recognizing and documenting deviations from expected configurations. 2. Assessment, evaluating the risk and impact of each deviation. 3. Planning, Developing a remediation strategy, including necessary approvals and change control. 4. Execution, implementing the remediation actions. 5. Validation, verifying that the remediation was successful and did not introduce new issues. 6. Prevention, implementing measures to prevent recurrence such as automation, policy enforcement, and regular audits. This systematic approach ensures that decisions are informed, risks are managed effectively, and the integrity of the cloud environment is maintained. Question 18. The monitoring system demonstrates a consistent pattern of increased network latency for a specific tenant's virtual machines residing on a particular workload cluster within VMware Cloud Foundation 5. 2. The latency is impacting application performance for that tenant. What is the most appropriate initial course of action for the VMware Cloud Foundation administrator? Option A. Advise the tenant that the latency is likely due to their application's internal processing and suggest they investigate their application code. Option B. Manually adjust the MTU settings on the NSXT edge nodes servicing the affected workload cluster without consulting the tenant or change management. Option C. Initiate a deep dive into vRealize operations and NSXT flow logs for the affected workload cluster and tenant VMs to identify potential network bottlenecks, resource contention, or misconfigurations. Option D. Immediately reboot all SC hosts within the affected workload cluster to clear any potential transient issues. The correct answer is C. Initiate a deep dive into vRealize operations and NSXT flow logs for the affected workload cluster and tenant VMs to identify potential network bottlenecks, resource contention, or misconfigurations. Explanation. The monitoring system demonstrates a recurring pattern of elevated latency on a specific workload cluster within VMware Cloud Foundation, VCF. 5. 2. This scenario is professionally challenging because it requires a nuanced understanding of VCF architecture, potential root causes, and the impact on service-level agreements, SLAs, without immediately resorting to disruptive troubleshooting. The administrator must balance the need for rapid resolution with the imperative to avoid unnecessary service interruptions or configuration changes that could exacerbate the problem or violate operational best practices. The correct approach involves a systematic, data-driven investigation that prioritizes non-disruptive methods. This aligns with best professional practices by adhering to a structured troubleshooting methodology, minimizing risk, and ensuring that any proposed solutions are well-informed and validated. Specifically, it emphasizes leveraging VCF's integrated monitoring and logging tools, e.g., vRealize operations, vCenter logs, NSXT flow logs, to pinpoint the source of the latency. This methodical approach is crucial for maintaining the integrity and performance of the cloud foundation, directly supporting the operational requirements and compliance standards inherent in managing a VCF environment. An incorrect approach that immediately involves rebooting the affected hosts or virtual machines without prior diagnosis is professionally unacceptable. This action constitutes a failure to adhere to established ITIL or similar operational frameworks that mandate root cause analysis before implementing corrective actions. Such a reactive measure risks masking the underlying issue, potentially leading to its recurrence, and could violate change management policies if not properly documented and approved. Furthermore, it demonstrates a lack of due diligence in understanding the VCF stack, potentially leading to unintended consequences on other services or the VCF management domain itself. Another incorrect approach would be to unilaterally reconfigure network parameters on the NSXT edge nodes or distributed switches without a clear understanding of the impact on the affected workload. This bypasses proper change control procedures and risks introducing new network instability or security vulnerabilities. It fails to consider the interconnectedness of VCF components and the potential ripple effects of such changes. A third incorrect approach might be to dismiss the latency as transient and wait for it to resolve on its own. This passive stance is professionally negligent, as it fails to proactively address potential performance degradation that could impact business operations and violate SLAs. It demonstrates a lack of accountability and a failure to uphold the administrator's responsibility for maintaining a stable and performant environment. The professional decision-making process for similar situations should follow a framework that includes 1. Problem identification and scoping. Clearly define the observed issue and its scope. 2. Information gathering. Collect all relevant data from monitoring tools, logs, and system configurations. 3. Hypothesis generation. Formulate potential causes based on the gathered data. 4. Testing and validation. Systematically test hypotheses using non-disruptive methods first. 5. Solution implementation. Apply the validated solution with proper change control. 6. Verification and monitoring. Confirm the issue is resolved and continue monitoring for recurrence. This structured approach ensures that decisions are informed, risks are mitigated, and the integrity of the VCF environment is maintained. Question 19. The risk matrix shows a high likelihood of a critical security misconfiguration being introduced during the rapid deployment of a new VMware Cloud Foundation 5. 2. Workload domain, with a moderate impact if exploited. Given the pressure to deliver this new capability to business users within the quarter, which of the following actions best mitigates this identified risk while adhering to professional best practices for cloud administration? Option A. Rely on the automated compliance scanning tools integrated within VMware Cloud Foundation to identify and flag any security misconfigurations post-deployment, addressing them as they are reported. Option B. Deploy the workload domain, and then immediately apply all available security patches and updates to the newly provisioned infrastructure components. Option C. Immediately halt the deployment and initiate a detailed review of all planned security configurations against the organization's security baseline and relevant compliance mandates before proceeding. Option D. Proceed with the deployment as planned and schedule a comprehensive security and compliance audit for the workload domain within 30 days of its go-live date. Correct answer is D. Proceed with the deployment as planned and schedule a comprehensive security and compliance audit for the workload domain within 30 days of its go-live date. Explanation. Scenario analysis. This scenario presents a common challenge in cloud administration, balancing the need for rapid deployment and feature adoption with the imperative of maintaining a secure and compliant environment. The pressure to deliver new services quickly can lead to overlooking critical security configurations or compliance requirements. The administrator must navigate this tension, ensuring that technological advancement does not compromise regulatory adherence or introduce unacceptable risks. The complexity of VMware Cloud Foundation, VCF, itself, with its interconnected components and extensive configuration options, amplifies this challenge, as a misconfiguration in one area can have cascading effects. Correct approach analysis. The correct approach involves a systematic review and validation of security configurations against established compliance baselines and organizational policies before proceeding with the deployment. This aligns with the principle of security by design and compliance by design, which are fundamental to responsible IT operations and are implicitly or explicitly supported by regulatory frameworks governing data protection and cloud security. Specifically, for a VMware Cloud Foundation 5.2 administrator, this means leveraging VCF's built-in compliance tools, such as those related to SDDC Manager's compliance checks, and cross-referencing them with relevant security best practices and any applicable industry-specific regulations, e.g., GDPR, HIPAA, PCI DSS, depending on the jurisdiction and data being handled. This proactive stance minimizes the risk of deploying a non-compliant or insecure environment, which could lead to data breaches, regulatory fines, and reputational damage. Incorrect approaches analysis. Deploying without a thorough security and compliance review introduces significant risks. This approach fails to uphold the administrator's responsibility to protect data and maintain system integrity. It directly contravenes the principle of due diligence, which requires proactive measures to identify and mitigate risks. Such a failure could lead to violations of data protection laws, resulting in substantial penalties and legal liabilities. Implementing security patches and updates after deployment without a prior comprehensive review of the entire configuration is also problematic. While patching is crucial, it does not address potential pre-existing misconfigurations or compliance gaps that were present at the time of initial deployment. This reactive approach increases the likelihood of security vulnerabilities remaining unaddressed or new ones being introduced by the patching process itself, if not carefully managed. Relying solely on automated compliance scanning tools after deployment, without manual verification and understanding of the underlying configurations, is insufficient. Automated tools are valuable for identifying deviations, but they may not capture nuanced compliance requirements or the context of specific business needs. A manual review ensures a deeper understanding and allows for the application of expert judgment to interpret scan results and validate configurations against specific regulatory mandates. This approach risks overlooking critical compliance issues that automated tools might miss or misinterpret. Professional reasoning. Professionals in this role should adopt a decision-making framework that prioritizes risk assessment and mitigation throughout the entire lifecycle of a VCF deployment. This framework should include 1. Define requirements. Clearly understand the security and compliance requirements dictated by the organization's policies and relevant regulations. 2. Assess risks. Identify potential security and compliance risks associated with the proposed deployment and configuration. 3. Plan and design. Incorporate security and compliance controls into the design phase, leveraging VCF's capabilities for secure and compliant deployments. 4. Implement and validate. Execute the deployment, rigorously validating all security configurations and compliance checks before bringing the environment into production. 5. Monitor and maintain. Continuously monitor the environment for security and compliance deviations and implement a robust patch and update management process. 6. Document and audit. Maintain comprehensive documentation of all configurations, security controls, and compliance activities, and be prepared for audits. This structured approach ensures that security and compliance are not afterthoughts but integral components of the deployment process, fostering a resilient and trustworthy cloud environment. Question 20. Compliance review shows that a critical security vulnerability has been identified in a production VMware Cloud Foundation 5.2 environment after initial deployment. The vulnerability could potentially expose sensitive customer data. The administrator is under pressure to restore full service functionality immediately. What is the most appropriate course of action? Option A. Immediately apply a known patch or configuration change that addresses the vulnerability without further analysis to minimize downtime. Option B. Temporarily disable the affected service until a permanent fix can be developed and tested, even if it means extended downtime. Option C. Document the vulnerability and plan to address it during the next scheduled maintenance window, assuming the risk of exploitation is low. Option D. Engage the security team to conduct a thorough risk assessment and impact analysis of the vulnerability, develop a remediation plan with rollback procedures, and then implement the approved changes. The correct answer is A. Immediately apply a known patch or configuration change that addresses the vulnerability without further analysis to minimize downtime. Explanation. Scenario analysis. This scenario presents a common challenge in cloud environments where rapid deployment and configuration changes are the norm. The professional is faced with a potential security vulnerability that has been identified post-deployment. The challenge lies in balancing the immediate need for security remediation with the operational impact of downtime or service disruption. The pressure to restore services quickly can lead to shortcuts that bypass established security protocols, creating a significant risk. Furthermore, the lack of clear documentation regarding the specific configuration and its security implications adds to the complexity, making it difficult to assess the full scope of the vulnerability and the potential impact of remediation efforts. The situation demands a careful, risk-based decision-making process that prioritizes security while minimizing operational disruption. Correct approach analysis. The correct approach involves a thorough risk assessment and a controlled remediation process. This aligns with best practices for IT security and operational management, emphasizing a proactive and systematic response to identified vulnerabilities. By engaging the security team, forming a detailed impact analysis, and developing a rollback plan, the administrator ensures that remediation efforts are well understood, their potential consequences are mitigated, and the integrity of the VMware Cloud Foundation environment is maintained. This methodical approach is crucial for adhering to security policies and maintaining the overall stability and compliance of the infrastructure. Demonstrates a commitment to security best practices, which are implicitly or explicitly required by regulatory frameworks governing data protection and system integrity. Incorrect approach is analysis. Implementing a fix without a proper risk assessment and impact analysis is a significant regulatory and ethical failure. It bypasses critical security governance processes, potentially introducing new vulnerabilities or causing unintended service disruption. This approach disregards the principle of least privilege and due diligence in system administration. Applying a temporary workaround without a clear plan for permanent remediation is also problematic. While it might address the immediate symptom, it leaves the system exposed to the underlying vulnerability, increasing the long-term risk. This can be seen as a failure to uphold professional responsibility for maintaining a secure and stable environment. Ignoring the vulnerability due to the perceived complexity of remediation or the potential for downtime is a direct abdication of security responsibility. This approach creates a significant compliance risk, as it fails to address known security weaknesses, potentially leading to data breaches or system compromise, which would violate numerous data protection regulations and ethical obligations. Professional reasoning. Professionals should adopt a structured decision-making framework when faced with security vulnerabilities. This framework typically includes 1. Identification and assessment. Clearly identify the vulnerability and its potential impact. 2. Risk analysis. Quantify the risk associated with the vulnerability, considering likelihood and impact. 3. Solution development. Research and develop potential remediation solutions. 4. Impact assessment. Analyze the operational and security impact of each proposed solution. 5. Planning and approval. Develop a detailed remediation plan including rollback procedures and obtain necessary approvals. 6. Implementation. Execute the remediation plan in a controlled manner. 7. Verification. Confirm that the vulnerability has been successfully remediated and that no new issues have been introduced. 8. Documentation. Record all actions taken and lessons learned. This systematic approach ensures that decisions are informed, risk-aware, and aligned with organizational policies and regulatory requirements.